Darren, take a look at this.
What is it?
I'm not sure. It could be a shark's tooth.
What are you two doing?
Hey man, check this out.
Take a look at this.
Yeah, so?
Man, aren't you even curious about what it is?
Not really.
Inquiring minds want to know.
Remember that video we saw last week about geology in science class?
Yeah, sorta.
Didn't it make you wonder about geology and how we can be affected by it?
Why should it? It doesn't affect me.
Are you sure about that?
That's what the video was trying to tell us. Sometimes we do things that affect the environment, and sometimes we're hurt by that.
And if we don't do something now about what we're doing, we're going to have bigger problems in the future.
Mr. Sanders told us about how geologists study the Earth to help answer questions about our environment.
Yeah, that sounds familiar. Keep talking.
We learned how sinkholes form.
And why landfills can threaten the water supply.
I'm beginning to remember.
What makes the planet Earth different from other planets in the solar system? Why does it support life? How long have humans lived on Earth? How long will humans live on Earth? Why is it important to study our planet? The planet Earth is just the right distance from the sun to have surface temperatures and abundant water to sustain living things. From the Earth, we get our drinking water and food, medicines and fabrics, materials to construct buildings, houses, cars, television sets, CDs, as well as the electricity to make these things work. Within its many layers are rocks, mineral deposits, and water that are necessary for human survival and comfort. But within these layers also exist materials and geologic processes that can threaten our survival. The Earth is a planet in constant change. As the human population grows and puts more demands on the environment, the conflict between natural geologic processes and human expansion becomes even greater.
Geology is the study of the planet Earth, the materials of which it is made, processes that affect these materials, the changes that the Earth has undergone in the past, and the changes it is currently undergoing. It's important to understand the geology of any area. The natural resources around us, such as rocks, minerals, and groundwater, can affect our health as well as our local economy. Maintaining a healthy balance between our impact upon the environment and natural systems is vital. We must learn to protect and conserve the Earth's natural resources for future generations.
Why is it that certain types of vegetation and wildlife prefer some areas and not others? The answer lies in the area's ecosystem. An ecosystem is any area where the Earth's living and non-living systems interact, including the air that surrounds our planet, the water bodies above and below the Earth's surface, the soils and solid surfaces of the Earth's outer layer, and all the organisms that live on the Earth, including humans. The shape of the Earth's surface is determined by geologic processes that control the location of uplands and lowlands, rivers, swamps, wetlands, and much more. When all these dynamic factors are added together in a specific area, certain types of vegetation and wildlife will thrive.
The waters of Florida Bay provide a home for numerous species of plants, fish, and shellfish. The health of these plants and animals depends upon Florida Bay's water chemistry. Even subtle changes in water chemistry can have widespread effects on the area's ecosystem. Geologists obtain samples of animal and plant remains from the sediments of Florida Bay in search of clues that will help them determine why its water chemistry changes. Over the past 200 years, significant changes have occurred in Florida Bay. Plant and animal remains indicate that variations in salinity occurred both before and after the influence of human activities in the Florida Keys. Factors affecting the waters of Florida Bay include climate, nutrient supply, length of wet and dry cycles, and human intervention. The results of geologic study have raised intriguing questions. How much of the changes in Florida Bay's water chemistry can be attributed to natural variations? How have human activities affected the water quality of Florida Bay? Further research is necessary to help us better understand the fragile ecosystem of Florida Bay.
It's really wild to think about 1.5 million years ago, this was covered by water of the Gulf of Mexico. Beach was down there, the waves of the Gulf were coming toward us, eroding this scarp we see before us here. And it turns out that in the state of Florida, most of the landforms are formed by the ocean. In peninsular Florida, we see tremendous numbers of coast parallel features, sand dunes, ridges, valleys, that are all formed by the action of the ocean on the land. Just like we see the erosion that occurred back here within the last 1.5 million years. The Cody Scarp, as seen behind me here, extends all the way across the western panhandle, almost to Jacksonville on the east coast of Florida.
Nice catch. I thought that one was going over your head.
Nothing goes over my head.
I thought everything went over your head.
Ooh, that's harsh, Julie. I remembered the part about ecosystems, didn't I?
Yeah, but there's a lot more to geology than just that.
I bet you've already forgotten that the basement underneath Florida was once part of Africa.
Or that mammoths and mastodons lived in Florida thousands of years ago.
What is this, Pick on Adam Day? Caverns form when limestone dissolves, and that can cause sinkholes.
You're getting there, man, but you still got a long way to go.
How safe is the area you live in? Are there any geologic processes that could affect your home? In Florida, there are several geologic concerns to human populations. Among these are sinkholes, radon, floods, unstable soils, and coastal erosion. What causes these processes? To find out, we have to travel back in time millions of years. Let's start from the beginning and work our way forward.
The study of ancient rocks indicates that the Earth is about 4.6 billion years old. If we set a clock at midnight, marking the Earth's origin, the first complex life forms, including trilobites, appeared about 530 million years ago, or about 9:14 p.m. The earliest fishes appeared nearly 500 million years ago, or about 9:24 p.m. Reptiles arrived around 300 million years ago, or 10:27 p.m. Dinosaurs roamed the planet from 230 to 65 million years ago, or from 10:48 p.m. to 11:40 p.m. Florida began moving to its present location about 195 million years ago, or 10:59 p.m. The first birds appeared around 150 million years ago, or 11:14 p.m. And humans began appearing just a couple of million years ago, or less than a minute before midnight. In the billions of years between the formation of Earth and the present time, geologic processes have been continually shaping the world.
The Earth's surface is divided into approximately 21 plates. These cooler plates float on and move with the hotter, liquid-like mantle which lies beneath them. As these plates slide past each other, earthquakes occur, like those in California. When one plate is driven under another, volcanoes may form, as seen in Japan. And when two plates collide, mountain ranges form, such as the Himalayas. The Mid-Atlantic Ridge lies on the border of the North and South American plates and the African and Eurasian plates. As the North American plate continues to move away from the African plate, the Atlantic Ocean widens at a rate less than 5 centimeters per year.
About 320 million years ago, major land masses came together to form a supercontinent called Pangaea. This ancient continent was composed of what is now North and South America, Africa, Europe, Asia, Australia, and many other land masses. Over a 200 million year period, the supercontinent split apart and the continents moved to their present location. The Atlantic Ocean formed as the North and South American plates and African and Eurasian plates moved apart. Part of what became Africa was left behind with the North American plate and formed the foundation for present-day Florida.
If you live in Central Florida, the deep basement rocks beneath your feet, roughly a mile or deeper, were actually once part of Africa. Now that's pretty amazing. But what's really amazing is how a geologist can tell what's going on that far beneath the surface of the Earth. One method combines the principles of geology and physics, or geophysics, to study the subsurface. Another way is being done here today by drilling a borehole. This is the Florida Geological Survey drill rig in South Florida, and they're drilling samples from depths of deeper than 200 feet beneath the surface of the Earth. As they bring these samples out to the surface, they lay them in special boxes where they can then be studied in laboratories. In these laboratories, the fossils can be looked at in these rocks. A geologist can interpret the ancient environment and determine that at one time this area was a beach. Geochemical analyses can be performed on these rocks to determine their age, or of course their chemical composition and their economic value, or how those rocks interact with groundwater. These rocks contain just a wealth of information. This is a core sample just taken out of the ground. Once several of these cores, maybe 3 or 4, are collected and analyzed, a geologist can then construct a cross-section or a slice of the Earth which shows the patterns in the subsurface, because they will have these physical samples from boreholes in the Earth, and they can be constructed and kind of strung together into this subsurface map or slice of Florida. Another way we can get information from these boreholes in the ground is through geophysical logging. In this type of data collection, a special tool, a geophysical tool, is lowered into the borehole by cables. As it is raised from the bottom of the hole, it measures different physical and chemical properties of the rock and water, and it sends that signal back up to the surface to a computer. This geophysical log can serve as a fingerprint of the package of rocks that are inside and surrounding that borehole at that point on the surface of the Earth.
Why doesn't Florida have earthquakes?
That's a good question. And to answer it, we need to understand how earthquakes form. There are 2 main geologic processes that cause earthquakes: active faults and volcanoes. Here, I'll show you. This shows earthquakes that have occurred in the Atlantic Ocean region since 1985. The larger the dot, the larger the earthquake. Look at how well the earthquakes line up with the plate tectonic boundaries. Now look at Florida. You can see it's far from any of these areas. Although recent geologic data suggests that there have been no earthquakes that have formed directly beneath Florida, since the 1700s, Florida has felt about 30 earthquakes. These earthquakes probably originated in the eastern United States or out in the Atlantic Ocean. This is why Florida is considered one of the most earthquake-safe places to live in the country.
The answer is blowing in the wind.
So that's where it went.
Hey, I'm doing a lot better than you thought. I remembered that there was this huge continent that split apart to form the Atlantic Ocean, and that Florida was once part of Africa.
What part of Florida?
What do you mean?
Like, all this sand. Was it part of Africa?
No. What's way underneath the surface was once part of Africa. All this other stuff came later.
He's starting to sound like a geologist.
Ooh, scary.
Geologically speaking, Florida is one of the most recently formed states in America. The Florida platform is a wide, relatively flat feature made up of limestone and dolostone. It lies between the deep waters of the Gulf of Mexico and the Atlantic Ocean, and was mostly underwater until about 24 million years ago. As the Appalachian Mountains eroded, some of their sands and clays were deposited in areas to the south. But the currents of the Gulf Trough kept these sediments from depositing over the Florida platform. After millions of years, the Gulf Trough was eventually filled, allowing the continuing formation of the Florida Peninsula as these sediments accumulated further south, intermixing with developing limestone.
We're standing in the middle of a quarry in central Florida. You can see behind me here there's just a tremendous section of limestone. This is a piece of the limestone, and the limestone is made up of fossils of shells and fossils of algae and coral and just a tremendous mix of different marine organisms. Over time, though, a lot of things work to mash it up, and they just mash and mash and mash and mash until finally there's nothing left but a powder. Now, the kinds of things that mash are waves, animals, starfish and octopus. Lots of animals will break shells to eat what's inside. And so over long periods of time, the shells become very fine-grained pieces of sand and even finer mud-sized materials. And that same material, after 40 million years or so, becomes a limestone. The most important thing to remember about dolostone is that they start off just like limestones. Same organisms and everything, but the difference is that these magnesium-rich waters percolate through and change the composition of everything. This piece is a sort of slabby rock, and you can see some fossils on here of seagrasses, just like the ones that live out in the bays today. This type of dolostone was formed in a shallow, near-shore, mud-flat type of environment just about the time that it was deposited.
Fossils give us clues to the ancient environments of our planet. Simply stated, fossils are the remains of plants and animals that can date back millions of years before humans inhabited the Earth. They can provide us with information ranging from how cold or hot an area was, to whether the area was a freshwater or saltwater ecosystem. Artifacts differ from fossils in that they are objects made by early humans, such as tools, weapons, and pottery, that give us clues about how humans lived thousands of years ago.
Justin, Stephanie, come on up. April and I just uncovered a sloth femur. This is the big leg bone of a sloth. And it's an erematherium, and so that gives us an idea that it probably died a little bit less than 2 million years ago. And we also found the jaw of a sloth over here too. It's probably from the same individual, so that means that it didn't transport very far. Okay, let's go over and look at the jaw. April uncovered this one. So you can see the teeth here. This is a pretty nice specimen.
Well, do you know how this died?
Well, we're not really sure. We assume that it either fell into the sinkhole or it got into the sinkhole in search of food or water. A lot of times these solution features will fill up with water and animals will come to drink at them and they'll fall in.
What other kind of fossils are found in this area?
Well, right here in this solution feature we find lots and lots of turtles. And so we know that at one time this big area, this solution feature, was covered with water. So it had water deep enough for large populations of turtles. We also have found giant armadillos. We find the remains of land snails, which probably fell in. We also find some leaves, and that's what these giant ground sloths would have eaten. They were browsers on trees.
All right, so what do these layers mean?
Well, you can see here that we've got a lot of clay and some sand. So we've got clays and sandstone, and that indicates that all this clay material here was deposited probably in water. We probably had alternating times of when this sinkhole, its solution feature, had water in it and when it dried up. But this clay was deposited probably when there's a lot of water in here, and it's really fine, and it buried these sloths fairly rapidly.
Imagine a world of ice, a world where giant sheets of ice move across the land, carving mountainsides, freezing and overtaking everything in their paths. During the Ice Age, these massive glaciers crept across the globe. Ocean levels dropped as the growing ice masses drew water from them, exposing areas of land that were once underwater.
The age of glaciation was marked by several periods of time when glaciers advanced and retreated over land areas. When the Earth's climate warmed, glacial melting caused the sea level to rise to heights as much as 100 feet above its present level. Much of Florida was underwater, leaving only a few islands where the peninsula is today. When the climate cooled again, glaciers expanded, dropping the sea level as much as 300 feet below today's level. As a result, Florida's landmass grew. About 6,500 years ago, the Earth's sea level settled into its present position, roughly establishing coastlines as we know them today.
Is sea level rising or falling?
Well, sea level doesn't remain stable. It rises and falls due to a number of reasons. Many scientists think that sea level has risen as much as 15 to 20 centimeters over the past 100 years. What's causing this? Well, it could be a number of things. Primarily among them
is the increase in carbon dioxide in the Earth's atmosphere due to burning of fossil fuels like coal and gas. Will this continue? Well, some people are predicting that it might rise by as much as 1 to 1.5 meters over the next 50 years. And so, is this a big problem? Well, I guess it depends on your perspective.
So, can he pull out?
Yes,
or?
you can.
Yeah, go ahead.
You
We're
sure?
done, right?
You're done?
Yeah.
Oh, okay. Okay, so Florida was once underwater, which means everybody was walking around like this, or learning to swim real fast. What was that for?
You're all wet.
Better start taking swimming lessons, brother. This beach might be underwater again someday.
Are you predicting another glacial melt?
Who knows? There are lots of things that affect the coastline.
Winds, waves, and erosion, to name a few.
Yeah, but that won't really change the shape of the coast in my lifetime, will it?
The coastline is a major battleground between the geologic forces of deposition and erosion. Winds, currents, waves, and plate movement can all affect shorelines, changing the very shape of the coast. These are natural processes that become threats to mankind as we continue to build homes and businesses near the coast. Processes such as plate movement, which can uplift the coastline in areas like California, and subsidence, lowering of the coastline in places like Louisiana, can take thousands of years to create noticeable change. But this can also happen in a matter of minutes in the case of strong earthquakes. Erosion and deposition by normal wave action can alter the shape of a coastline over many years. However, powerful hurricanes creating massive storm surges can alter shorelines in a matter of hours. Hurricane Andrew caused massive destruction as it pounded the coastal areas of southern Florida with wind gusts of 200 miles per hour. Likewise, Hurricane Opal caused extensive destruction to northwest Florida's Gulf Coast.
Beach erosion is one of the major environmental problems facing Florida today. Finding sand suitable for beach restoration is not an easy task. We've been out on the Gulf all day looking for sand deposits on the ocean floor. Onshore sand deposits are sometimes hard to find and expensive to transport. An alternative to that is dredging sand from an offshore source. In many areas, the seafloor is covered by bare rock. Areas of sand can accumulate on the rock, forming shoals. To find sand deposits that can be used for restoring beaches, we use geophysical data to help us see what the seafloor and the sediments below it look like. A transmitter sends out a sound signal through a set of transducers which are towed behind the survey boat. The sound energy is reflected off the seafloor and the sediment layers lying below the seafloor. The reflections are returned to the boat and recorded on a chart recorder. This gives us information about the seafloor and whether there are sand deposits that we can use for beach renourishment. Florida's beaches help bring over 30 billion tourist dollars to our state each year. We need to save our beaches for economic as well as environmental reasons.
Why are there so many sinkholes in Florida?
Florida is covered with a thin layer of sand and clay over limestone. Now, as rainwater percolates into this limestone, it begins to dissolve it away, and it forms massive caves and caverns. As these get larger and larger, eventually the ceiling will fall in, sand and clay will fall in on top of it, and you have a sinkhole.
Most karst processes are unnoticed because development occurs mostly underground over long periods of time. Chemical weathering is the predominant erosional process that forms karst features. Rainwater is slightly acidic. As it mixes with natural materials in the soil, it becomes even more acidic and dissolves limestone, creating holes that can enlarge over a period of time. The presence of unstable materials near the Earth's surface, such as clay, can create problems with roads and the foundations of construction projects. These clays do not have the strength to support buildings. Some clays swell or shrink upon drying or when wet, which can stress a building's foundation to the point of failure.
We're laying out a transect line. This transect is the imaginary line on the ground surface along which we're going to scan. We're going to put these intermediate distance markers in every 50 feet so that we can establish a horizontal scale on the GPR profile. We are conducting a ground-penetrating radar survey to look for buried sinkholes in Florida. The orange box is a radar antenna. It's transmitting pulses of radio waves into the ground. These waves bounce off of subsurface soil layers and rocks and return to the instrument and are displayed on a paper strip chart that looks, for all practical purposes, exactly like the depth finder on a boat. And that's a mark over. The radar waves are able to penetrate the sand just as if it was made out of glass. Therefore, we can see through the ground and observe the changes in the depth of subsurface soil layers. Oh, that's a really big one. This is amazing. That was a perfectly level field, and yet beneath it, there's a buried sinkhole that's over 100 feet wide and at least 30 feet deep. Here's the top of the clay layer, and it just drops off the bottom of the page right there. If a building was constructed on this site, it would be very important for the engineers to know that the thickness of the soils and the types of soils have changed rapidly in this one location. By finding these types of hidden geologic problems, we can save a lot of time and money and build much safer structures.
Sinkholes are dramatic examples of karst terrain. Brooks Sink, located in northeast Florida, is about 75 feet deep. Caverns are also examples of karst terrain, like the Mariana Caverns in the Florida Panhandle. As underground limestone continues to dissolve, karst features are created that divert more surface water into the underground drainage. This process can leave dry stream channels or disappearing streams that flow underground and reappear at distant points as springs. Many natural lakes in Florida are the result of karst processes.
Radon is a colorless, odorless gas which forms naturally from the radioactive decay of radium, a byproduct of uranium found naturally in soils and rocks. In Florida, radon is usually associated with phosphate and heavy mineral deposits. When radon accumulates in buildings or the basements of houses, it can become a health hazard for humans.
Floodplains, low-lying areas around rivers and streams, can become hazardous during times of heavy rainfall. Flooding occurs as water levels rise. If the water drains off at a slow rate due to saturated ground or clay beds underneath the surface, water levels could continue to rise even higher. The majority of river and stream-related flooding problems can be avoided by building homes and businesses away from floodplain areas.
Well, how can we protect ourselves from geologic processes?
That's a good question. The best way to protect ourselves is to understand how and why our natural systems work the way they do. Geologists like myself study the Earth's environment and its changing systems for that very reason. Think about where you live. If your house is near the coast, it can be affected by coastal erosion and storm surges. A house near a river or stream valley can be affected by flooding. Some types of clay beds underneath a house can cause its foundation to crack. Even high groundwater levels can cause a house to collapse. By studying these natural processes, geologists can help builders, land use planners, and government agencies when deciding where to build homes and businesses and how to protect water supplies. Natural geologic processes have been operating in the same way for millions of years. To protect ourselves, it is our responsibility to learn what these processes are and how they work.
With a little know-how and the right materials, mankind can build almost anything. Behold, a work of art.
Well done, Michelangelo.
Hey, this isn't bad for a mixture of sand and water.
Add a little gravel and limestone, and you've got Sleeping Beauty's castle.
What?
Concrete. Sand, gravel, and limestone are mined from the earth and then prepared to make concrete and cement.
Just like oil is pumped from the earth to make gasoline and asphalt.
Well, what would we do without good old Mother Earth?
Mining for resources is a major part of Florida's history. Over 12,000 years ago, Paleo-Indians dug the ground in search of chert, a type of rock they used to make tools and weapons. Florida's archaic people used sand, shell, and clay to make pottery. Early Spanish settlers mined coquina, a form of limestone made of broken shells cemented together. Coquina was used to construct buildings such as this fort in St. Augustine. Today, nearly 130 million tons of materials are mined from Florida's landscape each year for a variety of uses. These non-renewable resources cannot be replaced once they are mined from the earth, leaving future generations with the task of discovering alternative resources.
Florida has produced oil and natural gas for more than 50 years. Although we continually search for new resources of petroleum and other energy sources, drilling is only allowed if there is a minimal threat to the environment.
Limestones and dolostones are found at or near the surface in several general areas throughout the state. They can be mined in dry quarries by bulldozers or in water-filled pits by dragline or dredging.
Florida leads the nation in the production of phosphate, providing 80% of the U.S. output and 25% of the world output. Although phosphate is found in sediments throughout much of the peninsula, only 2 areas are currently economic to mine.
Heavy minerals are grains of sand made of minerals more dense than quartz and are associated with essentially all of the quartz sands in Florida. Heavy minerals are mined by a floating suction dredge equipped with a cutter head.
Clay is a general term for common materials which have a very fine particle size. 2 types of clay mined in Florida are kaolin and fuller's earth.
Sand is mined commercially throughout Florida and is used in the making of a variety of products. Gravel can be used to make asphalt and build roadbeds. Shell is also mined around the state for use in the production of roadbeds.
Cement is produced by heating a finely ground mixture of lime from limestone, silica from sand, alumina from clay, and iron oxide in a rotary kiln, then pulverizing the heated mixture. Masonry and Portland cements are produced commercially in Florida.
Another resource mined in Florida is peat. It is formed in poorly drained, waterlogged sites, such as estuaries, lagoons, the Everglades, riverbeds, lakes, marshes, and swamps.
An important part of mining for natural resources is returning the mined area to its natural state or transforming it for other uses, a process called reclamation. Without reclamation, further and more extensive damage can be done to the surrounding environment through stormwater runoff and erosion. Reclamation is a way of recycling land areas into natural wetlands, forests, housing developments, and other uses.
Nothing is more fundamental to life and natural systems than pure drinking water. Although 3/4 of the Earth's surface is covered by water, less than 1% of it is drinkable. Most of the drinking water in Florida comes from the ground, supplying 90% of the state's needs. The rocks in the aquifer systems allow water to move freely within them. The Floridan aquifer system is one of the world's largest and most productive aquifers. Florida's residents use almost 7 billion gallons of fresh water per day for residential, commercial, and agricultural purposes.
Water moves in a never-ending cycle between water bodies, land and air. When water in lakes, rivers, and oceans is heated by the sun, some of it evaporates into vapor. This vapor condenses into small water drops as it cools, forming condensation. Clouds are a form of condensation. When water vapor cools sufficiently, precipitation occurs in the form of rain, snow, or hail. Much of this precipitation finds its way into streams and rivers, which return the water into the oceans. However, some of the precipitation is absorbed by the roots of plants and is released as water vapor through their leaves. One way or the other, the water vapor is released into the atmosphere, starting the hydrologic cycle all over again.
Porosity is a measure of the holes or the pore space in a rock, a sponge being a great example. A sponge holds a lot of water, much like the rocks of the Floridan aquifer. Permeability is a measure of the ability of the rock to transmit fluid. Rocks with high permeability have a lot of pore space which is interconnected and allows the water to flow easily through the rock, like a sponge. Rocks with low permeability, even though they may have a lot of pore space, it's not connected and water does not flow through it very easily. Transmissivity measures the rate or the flow of the water through the aquifer. It's based on its width, its thickness, and the hydraulic gradient or the slant. The Floridan aquifer has high porosity, high permeability, and high transmissivity. In areas like this, where an aquifer has similar characteristics, it's very vulnerable to contamination from surface sources of pollution.
Threats to our drinking water supply come from many sources. More than 78,000 petroleum storage tanks are registered in Florida, most of which are underground. Fertilizers, pesticides, and other chemicals used by residents, as well as the agricultural industry, can pollute groundwater. 1 gallon of spilled gasoline can contaminate up to 1 million gallons of groundwater.
This is a really cool model that simulates the groundwater conditions in Florida, and it's in Florida's underground aquifer systems. What we're going to show, what we're going to simulate, is what happens when you get a leaky underground storage tank and possibly a leaky landfill, and how that might affect a pumping well and a stream. Okay, what we're going to do now is to take a red dye and introduce it into part of the shallow aquifer system as if a storage tank, an underground storage tank, were leaking. You can see the red dye coming into the system. We've already gotten some that's come through. See it come through this part of the flow pattern and has entered the stream. So we're getting pollution already across there in the shallow aquifer system to the stream. Now what I'm going to do is to draw some water out of one of these pumping wells and show how it will pull the polluted groundwater right into the well, and in this case, perhaps one of your drinking water wells. And there you can see the polluted water that's being pumped out of the well. Okay, what we're going to do now is to simulate a leaking landfill, the leachate coming out, the nasty stuff that comes out of the bottom of landfills. You can see the polluted water going through the shallow aquifer system. Here's our groundwater that's been pumped out for drinking. Now, would you want to drink something like this? I don't think so.
The age-old question of what to do with solid waste is difficult to answer as the accumulation of trash multiplies every year. Nearly half of it is recycled, almost 1/4 is incinerated, and over 1/3 is disposed of in above-ground or underground landfills, which can harm our drinking water. Hazardous chemicals found in household products such as detergents and cleaning solutions pose a serious threat to underground water supplies. Rainwater that enters unlined landfills seeps through the layers of decaying garbage and hazardous chemicals, making it contaminated. However, landfills today are constructed with liners to minimize groundwater contamination.
Don't litter.
Buy products with reduced packaging.
Use energy-efficient light bulbs.
Use rechargeable batteries.
Buy recycled materials.
Use silverware in China instead of paper plates and plastic utensils.
Composting. Recycle.
Humans are rearranging the Earth's landscape faster than natural forces such as rivers, glaciers, and wind. The activities of home building, road construction, and mining alone displace about 8 billion tons of Earth each year in the United States. This kind of large-scale development can harm farmland, ecosystems, and water supplies. But with the help of geologic data and research, environmental concerns are being addressed.
The disposal of liquid waste using injection wells is an alternative to surface water disposal. One thing we don't want to have happen at these type of disposal facilities is to have it come up again and come up into our underground sources of drinking water. This is an industrial injection well, and this disposes of brine reject water and industrial waste that is produced as a byproduct from a desalination facility operated by Sarasota County Utilities. This valve is opened up to the 12-inch force main, and this valve is opened up, and the brine reject water goes down this wellhead and for a total depth of about 1,900 feet below land surface. That's about 1/4 of a mile. And so understanding the geology, the geochemistry of the underlying formations is essential for this to be an adequate disposal system.
All right, you've heard about deep well injection in Florida. I'd like to tell you something about the shallow injection wells that are used here in the Florida Keys. And the limestone that they inject this material into is shown here in this cross-section. In fact, you can see the limestone behind me, and this is a model, a cross-section from where we're standing here all the way out to the reefs, which are about 5 miles just offshore from us. The sewage from these injection plants goes into the limestone, and it just goes in by gravity. They don't have to pump it like they do with the deep wells. And this is the limestone here, and I just pour a little water on it, and you can see it goes right through. So you can see the potential for any water with excess nutrients to flow under the ocean and seaward and pop up at various places, especially near the reefs where the permeability is very high. Well, as you can see, it's very important to understand the geology of the Florida Keys. Possibly we could learn how deep these wells should be, or decide whether we need disposal wells or alternate technology. And this is a big question in the Keys. In fact, it is the $64,000 question facing the Keys today.
One way of meeting the needs presented by commercial growth and development is the reuse of water. This involves taking what was once considered to be wastewater and putting it through a high degree of treatment. Then, the reclaimed water is used for beneficial purposes.
Stormwater runoff from surfaces such as streets, parking lots and lawns contain many pollutants, including oil products and heavy metals. Left untreated, stormwater runoff can damage ecosystems by polluting surface waters and underground drinking water in areas where aquifers are vulnerable to pollutants. Retention areas are a natural means of treating stormwater runoff before it reaches surface and ground waters. These areas contain grasses, plants, and microscopic organisms that filter out pollutants.
The proper disposal of contaminants such as household cleaners, motor oil, weed killers, and paint helps preserve the quality of our surface and groundwater. Here's a helpful list of things all of us can do.
Why is study of the solid earth and geology important? Well, let's think about that for a second. It's important because what do we do on the solid earth? We walk on it. We grow our food on it. We get our groundwater from it. We dispose of our waste on it. And we get all of society and cultural needs from the earth. What do we get from the earth? Well, let's think about our classroom. Think about this classroom. We look in the windows, we look at the floor, we look at the carpet, we look at the materials and things that are made up of your school. Think of the mall where your mom and dad go shopping. Think of your mom's or dad's house. Think of your car or the asphalt in the street. All of these things came from the earth. We have to find them. Geologists determine where they're found, where they're located, how to obtain them and mine them for our society's use. Geologic hazards is another area where geology has to provide input. Coastal erosion. Where are certain wave attack going to create a problem for buildings or structures on the coast? We have floodplain areas. We may have radon accumulations, and we've all heard of sinkholes. These geologic hazards are things that must be considered when we develop land for public use. Okay, we've seen how geology impacts society and our culture in many different ways. We try to estimate the economic input or what it really costs should we not do geology. Well, let's think of not having fresh groundwater, or if we build on a sand deposit where we may need to create cement for local building and we have to go 100 miles away and transport it, that's significant. Geology helps protect our environment, protect the fauna that lives there, and protect our public. You really can't put a value on good, clean earth, good, clean environment, and the future sustainability of our society.
population of Florida continues to grow, demands placed upon its natural resources will increase dramatically. In the beginning of the 21st century, Florida is projected to be the third most populous state in the country. Understanding Florida's environment has become a major focal point of public policy. Knowledge of Florida's geologic history, as well as its present geologic conditions, should lead to such decisions as where to build our homes, where we can find fresh drinking water, and where rocks and minerals can be found for mining. However, a lack of geological knowledge can have disastrous effects on future concerns.
We really have to understand the geology of this place, how this place came to be. You have to have a certain perspective, a certain idea of the sacredness of this place. These timeless principles still hold true. We still have to remember that what we did many years ago that worked, we still have to do today.
Concern for the environment and the effect we're having on it is a serious issue. That's why geologists and other scientists are working with engineers and planners to help solve environmental problems. Florida's water policy is just one example that addresses these concerns. The Department of Environmental Protection regulates facilities such as landfills, wastewater treatment plants, and gasoline storage tanks that can contaminate drinking water. This involves regulating the construction, operation, and monitoring of these facilities. Florida's water policy also helps protect lakes and wetlands, as well as our drinking water, by regulating the amount of groundwater withdrawal. This keeps the amount of surface water in lakes and wetlands at levels that won't harm these sensitive areas. The regulation of groundwater withdrawal also helps keep salt water from contaminating our drinking water. There's a fragile balance between our needs and the needs of the environment. We depend on the Earth's resources for many things, like food, water, electricity, and building materials. By protecting the Earth, we're also protecting ourselves. Through geologic knowledge and understanding, we can maintain a healthy environment and a healthy way of living.
Now I wish I'd paid more attention in class. There's so much more to geology than just studying rocks.
Uh-oh, he's finding geology interesting.
No, I'm serious. I want to find out more about geology and the Earth. I want to do my part to help protect the environment.
We'll talk to Darren. He's the geology major.
You?
Yeah, me. When I graduate, I'm going to study geology in college.
I didn't know you could major in geology.
Of course you can. Geologists have to learn about biology, chemistry, and physics, as well as geology.
You have to understand how all these different things relate to each other.
What kind of jobs are available after college?
Well, you could be a petroleum geologist. They look for oil and natural gas.
And hydrogeologists study aquifers, groundwater, and surface water.
Marine geologists study the oceans and continental shelves.
Paleontologists study fossils and ancient life.
Volcanologists study volcanoes, lava, and volcanic hazards.
All right already, I get the picture.
Glaciologists study glaciers.
Got it, thanks.
Seismologists study earthquakes.
Geochemists study chemical